presents Educational Satellite Television Programs.
Hello, teacher. Hello, students. In our most recent mathematics lesson, we continued our study of geometry and measurement by learning about two theorems. We use this theorem to figure out the similarity of plane figures, such as triangles. And we use this theorem to figure out the similarity of plane figures such as polygons. In this lesson, we are going to continue studying congruency and similarity by constructing similar figures. Then, we are going to use all that we have learned about congruency and similarity to solve some real-life problems. Let us start this lesson by learning how to construct similar figures. Please look at the screen. This is triangle ABC. And this is triangle DEF. Triangle DEF is exactly 2 times the size of triangle ABC. Another term for that is scale factor. The scale factor of these 2 triangles is 2. Now, watch as we find the center of enlargement. We draw straight lines through A and D, B and E, and C and F. We start each line from the point of the large triangle and extend it through the corresponding point of the small triangle. Where those 3 lines intersect is called the center of enlargement. Time for our first activity of this lesson. What I would like you to do, students, is take a look at the 2 similar triangles on the screen. Now, I want you to take what we just learned and determine the center of enlargement. Please go ahead and complete this activity.
Students, let's get ready. Begin. Let's get back to our lesson.
Welcome back, everyone. Were you able to determine the center of enlargement of the two similar triangles on your screen? Good. Let us work out the problem together. Please look at the screen. Watch as we find the center of enlargement. We draw a straight line from point A of the large triangle through point A of the small one. We do the same for the 2 point B's and the C's, making sure the lines are perfectly straight and very long. Where those 3 straight lines intersect is the center of enlargement. We label that point O. We can use this approach in reverse. Take a look at the polygon on your screen. Let us label it A, B, C, D. And let us place the center of enlargement here and label it O. Now, I want you to use what we have on the screen to create a similar polygon that is twice the size of the polygon on the screen. That means the scale factor of enlargement is 2. Please go ahead and complete this activity now.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back, everyone. Were you able to draw the second polygon? Good. It is not too difficult, is it? We simply draw straight lines from the center of enlargement through points A, B, C, and D on the polygon. The new points A, B, C, and D are located along the corresponding lines at points that are twice the length of the sides of the original polygon. Here, 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 and here. Now, we draw in 4 sides to make the larger, yet similar, polygon complete. Having this knowledge is important. People such as engineers, surveyors, and farmers use knowledge of congruency and similarity to solve problems in their everyday lives. You can use this knowledge to help solve problems around your homes, too. Let us try one right now. Please take a look at the image on your screen. A large tree casts a shadow. We can measure the length of the shadow because it lies along the ground. The shadow is 24 feet. But how tall is the tree? It does not make much sense to climb to the top of the tree and drop down a measuring tape. Yet, if we have a 3-foot-long measuring stick, we can figure it out. When we prop up that stick as if it were a tree, the measuring stick casts a shadow that is 6 feet in length. Now, we have all the information we need to determine the height of the tree. For our final activity for this lesson, please use what you have learned to solve this real-life problem. Go ahead.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back, everyone. Were you able to answer the question? Good. Let us go through it together. The trick is to think of the tree and the shadow and the measuring stick and the shadow as two sides of similar triangles. We perform the calculation this way. We start by writing the proportion. The height of the measuring stick, 3 feet, to the length of the shadow, 6 feet, is equal to the height of the tree, which we will call h, to the length of its shadow, 24 feet. We then find the cross products. If 6 multiplied by h is equal to 3 multiplied by 24, then 6h equals 72. We then solve the equation. H equals 72 divided by 6, which is 12. Therefore, the tree is 12 feet tall. Well done, students. You just solved a real-life problem using your understanding of congruency and similarity. You also learned how to construct similar polygons and determine the center of enlargement from two similar triangles. Good work, everyone. That is all for this lesson. Until next time, thank you, teacher. Thank you, students.